But anyways, here we go. We're on sum and difference identities. It's a new identity that we'll be adding to our bank of identities. So as we get close to Friday and you start making your note card, on your note card, should you be including these identities?
Yes.
Yes, unless you have a big brain and you want to just memorize them. 100% up to you. But you will have your little standard note card. If you don't, they're in the note card bin on the table. But just make sure you're putting those identities so that you know what's what, right? All right, so we're on sum and difference. So we can use the cosine sum and difference identities to derive similar identities for sine and tangent, okay? So the beauty about identities is that it's a pattern that someone recognized and they created a rule. That's what made it an identity. The identity then can also be manipulated to create more rules, more identity, more things for us to follow, and more patterns for us to recognize. So for example, if I have the cosine of A plus B, with the sine of A plus B, we can use cofunction identity to substitute in. So using the cofunction identity, we know that that means that 90 minus A plus B degrees, the cosine of that is going to be equal to it. So that's using the cofunction identity, which we learned last week. Do you remember cofunction identities? Okay, we can clean this up and simplify. So we end up with cosine of 90 minus A minus B. And then we can insert more, substitute in values. And once you come down to the end, the final identity, I'm going to get to it, is this. That's what you're writing down, by the way, not that stuff. No, I just wanted you to see the proof for a little bit. So exactly. So last week we did cosine sum and difference, right? Now we're doing the sine sum and difference. So for sine sum and difference, it's going to be alternating sine and cosine. Remember, cosine was cosine, cosine, sine, sine. You remember that? Cosine, cosine, sine, sine. This time we're alternating sine, cosine, cosine, sine, sine, cosine, cosine, sine. And that's going to be for your sum and difference of sine. All right, so just like before, we're going to be given a function, a plus b, or we'll be given the rule, the expanded identity, and we have to figure out the angle, right? So let me know, give me a thumbs up when you've written it down so I know when to click on. There, wait on a couple more, boom, boom, boom. You're good. Today's an easy breezy day. It's just a repeat of cosine. Yeah. Here's the formula. Here's your identity. Yeah. All right. So here we have tangent. Tangent is our next one. So there's a tangent. It's going to have 3. So we're going to write the sum and difference for tangent. Ignore the rules. I'm going to just go to the thing. I knew you didn't want to see the proof. I flipped through it. Here are your sum and difference. Are you sure you don't want us to go through the reasoning? Nobody? I was trying to be different, you know. No, you just need to know the identity. This is not an analysis class. All right, so tan of A plus B, so angle A plus angle B equals tan of A plus tan of B divided by 1 minus tan of A times tan of B. Tan of angle A minus angle B is going to be tan of A minus tan of B divided by 1 plus tan of A tan of B. As you can notice, the numerators are going to be the same as the original operation. The denominator is going to be the opposite. The numerator is the same operation. The denominator is the opposite. You see it?
So you know, for like sine and cosine, you get like the difference from the circle. For tangent, you
have to use y over x. Yep. Tangent gets a little more work for you there, huh? All right, so we got we now have all of our sums and differences. We have cosine from 5.3. Now we have sine and tangent from 5.4. Yes? All right, so let's start off with an example. So if I wanted to find the exact value of sine of 75, right? So the first thing I want to ask myself, what two angles that I know of on my unit circle can be added or subtracted to give me 75? 30 and 45, right? So 45 plus 30 would be the two angles that I would use. Are you with me? Okay, so that means that my A would be 45. And my keyboard's not keyboarding. My board's not boarding. Let's try that again. There we go. A would be 45 and B would be 30. And now I'm just going to plug them into the identity. Yep, easy enough. So I'm going to plug them into the identity where they go. So we have sine of 45 times the cosine of 30 plus the cosine of 45 times the sine of 30. And we're big brain, so we should be able to fill these bad boys in, right? What is the sine of 45? Square root 2 over 2. What is the cosine of 30? 1/2. What is the cosine of 45? Square root 2 over 2. And what is the sine of 30? Square root 3 over 2. So we plug in those values. I think you had it switch though. For cosine and sine. For this one. For x, y. Yep. Okay. And again, these are our ordered pairs, right? On our unit circle for those angles. And when you are multiplying, it's numerator times numerator, denominator times denominator. So for our first term, we have square root of 2 times square root of 3 makes it square root of 6 over 4. 2 times 2 is 4. Square root of 2 times 1, all over 4. So we have square root of 6 plus square root of 2 all over 4. How do we feel about it with degrees? But we're good. We're great with degree. I believe in you. I knew you could do it. All right, let's try our radian. And we're doing tangent now. Did you say disgusting? It's not that serious. All right, so we have 7 pi over 12. So again, think about this, that your entire top half of your unit circle is divided into 12 parts when you think about it, right? You can be divided into 12 pieces, all the way across, 12 equal pieces. But I need to make 7 pi. How can I make 7 pi? And the thing you're going to think about is putting your values in terms of 12s. So for example, if I have pi over 4, that equals how many 12s? What would I have to multiply 4 by to make it a 12? So it equals 3 12s. If I have pi over 3, what would that equal in 12s? 4. Oh my God. Oh my goodness. So what two radian values can we use? Pi over 4 and pi over 3. Because when you add those two together, they equal? Yep. And you're just adding till you just get the value of that radian that you want. See? And y'all thought it was harder than what it was, right? No, you're just going to look at what the denominator is that's given to you and think about your values and convert them to that denominator. Was that bad? It was not. So we know we're using pi over 3 and pi over 4. Okay, now, America brought this up earlier. When you're finding the tangent of something, that means it's your y divided by your x, right? So when we're looking for the tangent of pi over 3, we're gonna have to divide what? Square root of 3 over 2 by 1/2. So square root of 3 over 2 divided by 1/2 is just square root of 3. Does that make sense? Because you have to find the tan of each one of these. So we need to know the tan of pi over 3, which is square root of 3. And we have to know the tan of pi over 4, which equals tan of pi over 4. Square root of 2 square root of 2 over 2 divided by square root of 2 over 2 is 1. Because anything divided by itself is 1. So we're going to find those values. We're going to find the tan of pi over 3, tan of pi over 4, which we already know. And now we're going to do what? Plug it in, right? We already know the values. So we're going to plug everything in where they go. At this point, your job is to simplify. Simplify means get it down to the least amount of characters. Okay? So notice here, in order to simplify it, we have to ratify our denominator. Ratifying our denominator means we're doing the opposite of what's taking place. So in our denominator, we currently have 1 minus the square root of 3. To get rid of that, we're going to have to multiply the numerator and the denominator by 1 plus the square root of 3. Because again, the goal is to get it down to the least amount of characters as possible. That's what simplify means. If it had been 1 plus the square root of 3, then to ratify, we would have did 1 minus the square root of 3. Okay? This means that you have two binomials next to each other. And how do you evaluate two binomials? What do? FOIL. So you have a binomial in the numerator. Two binomials in the numerator is being multiplied. Two binomials in the denominator being multiplied. So we're going to FOIL. By the time we're done foiling, this is what we come down to. Okay, so notice here you have square root of 3 times square root of 3. That sets the root 3, so that's why it's 3. You have 1 times 1, which is 1, and then 1 times the square root of 3. Your denominator, because they're opposite, your insides, the O and the I are going to cancel out. So all you're doing is 1 times 1 is 1, and negative square root of 3 times positive square root of 3 makes negative 3. Combine like terms. So our like terms in the numerator are 3 and 1, and 1 square root of 3 and 1 square root of 3. Do we see that? So when we combine like terms, we come down to 4 plus 2 square root of 3. Is this fully simplified? No, why not, Johnny? The 2's, everything can be divided by 2. So we're going to divide every term by 2. And when we divide every term by 2, this is what we come down to. 2 minus the square root of 3. So when it says simplest form, this is what it means as your result. I'm sorry.
I have a question.
See.
So with this, right?
Mhm.
It's just 3 plus 1 equals 4.
Yep. This is 1 square root of 3 plus 1 square root of 3, which makes this 2 square root of 3. Yep. So your radicals kind of are treated like a variable as long as they're the same. So there's a Casper the Friendly one right here. So I have 1 square root of 3 and 1 square root of 3, which made it 2 square root of 3. All right, so tangent would be our most involved, especially tangent with a radian. How do you feel about tangent with the radian? It's doable. A little more work, but doable. Okay, now we're gonna go backwards. Okay, so going backwards, that means we're establishing which one do we use. All right, so off the back, we know that our angle A is 40 and our angle B is 160. We go, But you got to decide, and I'm subtracting. So which sign am I using? which sign, sum or difference? It's gonna be the opposite, so we're gonna be using, is it opposite on sine? No, sine is the same, right? It's difference, sorry. We're doing difference, no. So this equals the difference. That means that I'm doing what with these two angles? Subtracting them. Cosine is the opposite. Of course, x's. Oh. Always lying and making things complicated. Okay, so once we establish our A and our B and which one of our sum and difference identity we use, then we just start working it. So 40 minus 160 is negative 120. So you either can work the problem as negative 120 or you can find its coterminal. How would I find its coterminal? Well, mathematically, you're adding 360, right? So to find my coterminal, it would equal sine of negative 120 plus 360, right? And that would put me at what? $240, right? So that puts me at 240. So I'm looking at the angle of 240, or I can take the fact that I'm going to use it as a negative. So either way, it's going to still be the same. So you either can look at it as angle sine of 240, or you can look at it as the negative sine of 120. I sometimes just say find the cofunction. I feel like if you find the coterminal every single time and just go from there, to me, it's still going to lead you here. If we go to 240 on our unit circle, what is its sine, its y value? What? Negative square root 3 over 2. And is that what we get? Okay. So do we see how going backwards? They give us the expanded identity. We condense it, find the value. Yeah. Okay. What if I only have one A? What's happening? We're gonna figure it out. We're gonna see
It's like not a different answer, but you're trying to find like.
create another identity from it. Yeah, I know. Here we go. All right, so this is your A, this is your B, right? What did we learn from sum of cosine last week? So it's gonna be cosine minus sine. You remember that? So when I expand it, it becomes cosine of theta times cosine of 30 times cosine of theta minus sine of 30 times sine of theta. And now we're going to find cosine and sine of 30. What's the cosine of 30? Square root of 3 over 2. And what's the sine of 30? 1/2. So we're going to plug those values in. And we're going to combine them. The reason why we combine them is because they have the same common denominator. Do we agree? The denominator, even though it's only on the 2 is going to apply to the cosine and the sine as well. So we're going to combine them with one denominator. And that's as far as that will be our answer. So when would this be useful? For example, if I had an angle, let's say it was 150. So if I was looking for the cosine of 150 and I broke it down to be 30 plus 120, that means that all I have to do is plug in the cosine of 120 and the sine of 120, and I would find my answer. So if I can make it in a rule of 30 degrees. All right, so now we're going to do tangent of 45. So tangent of 45 minus theta means I'm going to have tan, can't talk, tan of A minus tan of theta over 1 plus tan of 45, tan of theta. Okay, so what's the tan of 45? It's just 1, right? Square root 2 divided by 2 divided by square root 2 is 1. So tan of 45 is gonna be 1. So what this leads us to is that whatever the B value is of that angle, then I just gotta plug that in. So let's say we had, I'm trying to think. My brain's not thinking very well. 135? Yeah, let's do 135. So if I was asking what's the tan of 135, I know that I could subtract 45 from that, and then whatever's left with, that angle is all I have to plug in to find the answer. Instead of doing the whole spread that we did. If I can make it a rule of 45, a difference with 45, then I just only have to do this. Does that make sense? It's like trying to create a shortcut. So let me write it. Let's see if this works. My brain is not brain. 180. Trying to think of a number 45 plus. 20? Yeah, let's see. So let's say you had 45 minus 20, right? I know it's not gonna be in our unit circle, but let's say you had 45 minus 20. If this minus 20, instead of doing everything, all you have to do is just plug in the 20 for theta. That's because 45 is gonna always be what? 1. So all you have to do to find that angle is to plug in 20 for theta. Or if you had 45 minus negative 10, all you'd be plugging in negative 10 instead of going through the whole thing and plugging everything in. Okay, this is just a shortcut creation. You can just use the identity as it is. All right, same thing here. So for example, if my angle was cosine of 30 plus 45, which we already did, to get my answer, all I would do is plug in cosine of 45, sine of 45, and that would be the answer divided by 2. So it's like, oh, you could use this rule to find a shortcut, but you don't have to. All right, last one, sine of 180. Sine, again, is alternating between sine and cosine. It's not CC, is CS, SC. So you have the sine of 180 times the cosine of theta minus the cosine of 180 times the sine of theta. Okay, where's 180? Where's it located on a unit circle? Negative 1, 0. So that means that this is your, ooh, can't believe I was about to write that. That means that this is your cosine. And this is your sine, right? So when I plug those values in, what's going to happen here with sine of 180? It's going to become 0. And then cosine is going to become negative 1. So what happens to this whole first term? Cancels out. And a negative times a negative is a positive. So it just becomes sine of theta. So what this is telling you, if you had sine of 180 minus 35, all you would do to find that answer is plug in 35 for theta. So if it comes down to you being able to split it to be 180 minus something, then all you're doing is plug in that one value to find your sine. Could you do the whole side, the whole rule, the whole identity? Yes, you could use the whole identity. Again, these are just shortcuts of the identity. Okay? You can always just do the full identity like we did before. Okay? All right, where are we at? So based on your quadrant, you have to pay attention to what's taking place. So it says, suppose that A and B are angles in standard position, with sine A being 4 over 5, and A being between pi over 2 and pi, which means it's in what quadrant? Quadrant 2. Does that make sense? And cosine of B is negative 5 over 13. And B is between pi and 3 pi over 2. So what quadrant are we in? 3. So our two angles are drawn in 3. So when you're looking at this, it's going to go back to our previous knowledge of angles and being drawn. So if I have sine A 4/5, that means my y and my r. Do y'all remember that? Your y. So that this angle is up 5 and up 4 with a radius of 5. So what is going to be the x value? What kind of 3 though? It's a -3. So for this one right here, this angle alone, A, we know that the cosine of A equals what? X over -3/5. And we know that the tangent of A equals y over x. -4/3. Okay, now we're going to model the next angle it told us, which is cosine of angle B. It is drawn in what quadrant? 3. So on this one, we have a radius of 13 because cosine is x over r. We've gone out 5. And we're going to pretend that that is a right angle happening at y'all's. Yeah. That's some beautiful drawings for y'all. And y'all are going to accept that that is a right triangle. Okay. Thank you for your cooperation in this matter. I can't even accept it, y'all. I tried. Oh my gosh. Look here. That was a low blow, Andrew. I'm fixing it. So y'all can't make fun of me. I'm not an artist. Okay. All right. So if x is -5, radius is 13, what is our y? Anyone remembers? It's one of our Pythagorean triples. 12, 5, 12, 13.
Don't remember.
It's the same triangles over and over. 5, 12, 13, 3, 4, 5. Pythagorean triples. All right. So for angle B, we have sine of B would equal what? -12/13. And then we have tan of B would equal a negative divided by negative is a positive. And we're in quadrant 3, so tangent is always positive. Okay. So now we have all of our values, right? So now that you have all your values, can you evaluate sine of A plus B? Yes. Can you evaluate tan of A plus B? Yes. And then can you figure out what the angle A and B are? Can you figure out what angle A and B are together? What they make together? You can. All right. So this is where I was going to let you guys, what time is it? Practice using your identities. So using the sine sum first, and then the tan sum. And then we will check and see what you got. Go.
I just do polyline because you get the high bar.
Okay, here we go. So your cosine is x over y. So now we're going to go through the process. So remember, you have all of your values that you need and you've written them down. So let's start with the first identity, sine of A plus B. It involves us having sine of A, cosine of A, sine of B, cosine of B. Okay. So we know that A is in quadrant 2 and cosine A is negative and tan is also negative. So you could go through the whole thing with sine squared plus, you can use your Pythagorean identity to find your cosine, or you could do what we did using our right triangle trig to find our cosine. Either way, it's perfectly fine. So now you have your sine and cosine value. You're going to do the same thing for B. You're going to plug in -5/13, plug it in, take the square root, get -12/13. So again, you can use your right triangle trig and still get to the same values of this. All right. So now tangent. So we're going to need tangent of sine A and cosine A. Tangent is sine A divided by cosine of A. So you know your sine A and your cosine A. So that's going to give you -4/3. Tan B, sine B divided by cosine B. And that's going to give you 12/5. So these are alternative ways of finding your sine, cosine, and tangent for angles A and B. Okay. Again, you can always just use the right triangle method and go from there. So now we're ready to plug in. So sine of A plus B, the identity is sine A times cosine B plus cosine A times sine B. We're going to literally substitute in those values. So we know that sine of angle A is 4/5. Cosine of angle B is -5/13. Cosine of angle A is -3/5. Sine of B is -12/13. And we're going to multiply and combine. So we end up with -20/65 plus 36/65, which equals 16/65. So we have a positive sign. So from here, we know that sine is sine of A plus B is positive. Okay. So that narrows it down to our angle being in either quadrant 1 or in quadrant 2. All right, up next, we have tan of A plus B. Tan of A plus tan of B divided by 1 minus tan of A times tan of B is the identity. So we're going to plug in, substitute in the value for tan A and tan B. So we substitute in those values. We're going to combine like terms, not like terms, evaluate. So in the numerator, you can do a little chopstick and bowl. So that gives you -20 plus 36, which is going to give you -16/15. And then in the numerator, you're going to multiply. Well, positive. Was it positive? Yeah, it was positive because 36 is bigger. And then the numerator, you're going to multiply and then subtract. And that gives you 63/15. Remember, when you're dividing fractions, you're going to keep, change, flip, aka multiply by the reciprocal of the denominator. And you're going to end up with 16/63. So that tells us that our tan of A plus B, so tan of A plus B is positive. So it narrowed it down to quadrants 1 and 2, but since tan is also positive, that eliminates quadrant number 2. So to answer our question, the quadrant where sine and tangent are both positive is in quadrant 1. So that means that the angle A plus B combined has to be in quadrant number 1. All right. And lastly, we have verified the equation is an identity. So this is us working backwards. It wants us to verify that this bad boy will somehow condense down to this. Okay. So we're going to be using our sums of cosine and sum of sine identities to expand upon. So the first thing we're going to do is expand both identities. So when we expand both identities, this is what we look like. We then are going to substitute in the values that we do know. So we know the sine of pi over 6, cosine of pi over 6, the cosine of pi over 3, and the sine of pi over 3. So all I'm doing, again, took this and it became 1/2. I took cosine and it became square root of 3 over 2. We have cosine of pi over 3 and it became 1/2. And we have sine of pi over 3 and it became square root of 3 over 2. Okay. After I do that, I'm now going to combine like terms. So we're going to combine our like terms. Our like terms. So our first set of like terms is going to be our cosine. So we 1/2 cosine plus 1/2 cosine. And then we're going to combine our sines. We have positive square root of 3 over 2 combined with negative square root of 3 over 2. And when we combine our positive and negative square root of 3 over 2 sine theta are going to cancel out. And we're just left with 1/2 cosine theta plus 1/2 cosine theta. And 1/2 plus 1/2 equals A. So wham, bam. We have now proven using our sum that this is equal to cosine theta. All right, that concludes 5.4. Complete your work.